Okay, hey guys, so today we are going to learn about ionic compounds with polyatomic ions. Okay, so your polyatomic ions are groups of atoms that behave as one unit. So on the back of your periodic table, well, these right here are your polyatomic ions, but on your periodic table, this is where they are right here. Okay, so all this right here, this left side of the back of your periodic table, these are all your polyatomic ions. Okay, you don't have to memorize them, but you do have to be familiar with what they are. Okay, so back to our notes. So these are your polyatomic ions. Okay, I've had a lot of students today get confused about, okay, so which is part of your polyatomic ion? So if you have NH4, then NH4 is your polyatomic ion. Okay, this plus at the top, this is going to be your charge. Okay, so CO3, so your polyatomic ion is CO3, and then the charge, that second number up top, that's your charge. So CO3 has a charge of -2. Okay, so please be careful when you guys are looking at your polyatomic ions. Don't confuse which one is your subscript and then which one is your charge. Okay, so they are treated like single ions in formulas, but use parentheses. Okay, they use parentheses. Gosh, I hope that spelled that right. I have a feeling I didn't. English was not my best subject. Parentheses. Okay, I did? No, I didn't. Okay, so parentheses. Okay, so basically what's that saying is, let's use carbonate as our example. So if I have one carbonate, it's going to look like CO3, and that's it. But if I have more than that, it's going to look like CO3, then parentheses 2. So that's telling me that I have 2 CO3s. Okay, this is what that means. Okay, so never change the look or the name of your polyatomic. So if you change the subscripts for any part of your polyatomic, then it's no longer the same polyatomic ion. Okay, so our examples, NH4 is going to be different as NH. Okay, and it has everything to do with your subscript. For this one, you only have 4 hydrogens. This one, you only have 1. Okay, these are still considered polyatomic ions. Okay, so otherwise, use all the same rules for naming and writing compounds as with any other ionic compound. Okay, so really the only big thing here is now we have polyatomic ions, okay, and we need to use parentheses to separate our polyatomic ions and how many we have of each. Okay, so let's go ahead and take a look at our practice ones. Okay, so let me see. Okay, let me go ahead and zoom in if I can. And it won't let me, so I guess I won't zoom in. Okay, so remember, if we have Al3CO3 -2, so remember we always crisscross our charges, so that means that my aluminum +3 is going to become a subscript for cobalt. Okay, and then our -2 is now going to become a subscript for aluminum. Okay, so our formula is therefore going to be Al2, because that's 2 is now a subscript for aluminum, and 3 is now going to become a subscript for CO3. So remember, we have more than one CO3 now. So parentheses, CO3 and 3. Okay, so again, our charges, we crisscross them. They are going to become the subscripts for the opposite element. So aluminum is now going to have a subscript of 2, and CO3 is going to become a subscript for, your charge from aluminum, positive 3, is now going to become a subscript for your polyatomic ion CO3. Okay, so when naming them is really easy. Okay, so what is your first metal? Well, that's aluminum. Okay, and then what is your anion? Well, your anion is CO3. So on the back of your periodic table, okay, I wonder if we can zoom this in. We can. Okay, so on the back of your periodic table, I'm just going to get rid of my face because y'all don't need to see me. Okay, so on the back of your periodic table, let's take a look. So, Okay, so what is CO3 on the back of our periodic table? So CO3, it's in alphabetical order. So CO3 is right here, and it's carbonate. So aluminum carbonate. Okay, so the next one, same thing here. I can zoom in. Okay, so the next one, same thing here. Okay, so we have calcium, positive 2, NO3, negative 1. So what are we going to do? We're going to crisscross our charges, and they're going to become the subscripts of the opposite element. So 2, my negative 1, it's going to become the subscript for the opposite element. So then I have Ca with a 1 subscript, and then I have NO3 with a 2 subscript. Okay, remember your polyatomics, they are a family. They don't like being separated. So really, when you see a polyatomic, don't mess with that 3. Don't mess with their subscripts. Just leave that subscript alone. Okay, you're only bringing down your charges. Okay, so again, naming them. What's your first metal? Calcium. Okay, and then check the back of your periodic table. What is NO3? Okay, so NO3 is this one right here. So it's nitrate. So calcium nitrate. Okay, let's do the next example. We have potassium, positive 1, and ClO3 with a negative 1 charge. So remember, if your charges are the same, they're going to cancel each other out. Okay, so you're going to end up with no subscripts. Okay, so then your formula is therefore KClO3. Okay, and then to name it, well, what's your metal? Your metal is potassium. Okay, and then what's ClO3 on the back of your periodic table? So ClO3 is right here, so it's chlorate. Okay, so CHLORATE, chlorate. Okay, all right, so let's go ahead and do a few more examples. Okay, so name the following compounds. Well, remember, naming is really easy. All you have to do is, what's your metal? Barium. And then what's your polyatomic? Okay, so in parentheses, that's my polyatomic, OH. So on your periodic table, OH is right here. Now it's going to be hydroxide. So the name of my compound is barium hydroxide. Okay, next one, we have calcium, so Ca, and then SO4. So calcium. And then what's SO4 on your periodic table? SO4 is right here. So that's going to be sulfate. Okay, so calcium sulfate. Okay, the next one, we have NH4 3P. Okay, so NH4, since that's in parentheses, this is my polyatomic. So NH4 is right here, and that's going to be ammonium. Okay, now my anion, it's just a single element, so it's not a polyatomic. So if it's just a single element, it's going to be phosphide. Okay, so there's a few things that I do have to point out to y'all. If y'all take a look at some of the names of these compounds, you have carbonate, you have nitrate, chlorate. Okay, some of these, they end in ATE or they end in ITE. So some examples, you have sulfate and sulfite, you have nitrate and nitrite. Okay, so if you take a look at them, a lot of them are going to end in ATE or ITE. So if it ends in ATE or ITE, then you know it's going to be a polyatomic in the back of your periodic table. Okay, but if it ends in IDE and it's just a single element, then it's going to be just a regular non-metal on your periodic table. Okay, so you're probably have one of these right here. Okay, so these non-metals are going to end in IDE. Okay, so just like phosphide, since we only had one element, it's going to be considered just a regular ionic compound. Okay, so you would name it just like that. Okay, so IDE. Okay, so let's go ahead and keep going for the last few examples that we have. Okay, so let me close this, make this a little bit smaller. Okay, so strontium and phosphate. So which one is going to be your cation? Which one's going to be your anion? And then we got to make a formula. So remember, your cations are always your metals, and they are always first. So your cation is strontium, so Sr. So strontium on our periodic table, let's take a look. Where's strontium? So strontium is right here, so it has a charge of +2. Okay, so Sr, +2. Now my anion is going to be phosphate. So on the back of your periodic table, okay, phosphate, I'm just going to leave it like this since we're going to be going back and forth a lot. Okay, so strontium, phosphate, phosphate is right here. So your anion is therefore PO4 with a charge of -3. Okay, so when you make your formula, don't forget that you are crisscrossing. So the 2 is now going to become a subscript for PO4, and then your 3 is going to become a subscript for Sr. Okay, so Sr3, and then parentheses PO4, because they're a family, they're best friends, you don't want to separate them. PO4 now has a subscript of 2. Okay, all right, so next example, we have lithium and acetate. So lithium is going to be our metal. So lithium, okay, lithium is right here. So that's going to be a group 1 element with a +1 charge. So Li, +1. And then acetate. Acetate is on the back of our periodic table, so let's take a look. Acetate is right here. So you have two options. It doesn't really matter which one you use. I normally use this one just because it's first. So it's going to be C2H3O2 with a charge of -1. Okay, so -1 charge. So remember, do I need to crisscross my charges? And the answer is going to be no, because they cancel each other out. So your formula is LiC2H3O2. Okay, and then your last example, we have sodium sulfate. So sodium on our periodic table, we have another group 1 element. So sodium is Na positive. And my anion is going to be that sulfate. So on the back of our periodic table, sulfate is right here. So that's going to be SO4 with a -2 charge. So SO4 with a -2 charge. Okay, and now we have to crisscross. So sodium is now going to have a subscript of 2, and then SO4 is going to have a subscript of 1. So your formula is Na2SO4. And then do we really need parentheses for this one? No, because you only have one polyatomic. Okay, so no parentheses. Notice how we didn't use parentheses for this one either, because we only have one polyatomic. Okay, but for this one, PO4, it did need parentheses. Okay, because we have 2 PO4s. Okay, I do want to bring up something that you guys have on your homework. Okay, so for your homework, please be careful. When it asks you for a formula, oops, it would help if you guys can see it. Okay, so if it asks you for a formula for a polyatomic ion, well, of course, you're going to use the back of your periodic table. Okay, so your formula is going to be C2H3O2. You don't want to include a charge, because a formula does not have charges. So your ion charge, that's where you would include your negative or positive sign. Okay, so my charge is going to be -1. Okay, so let's do another example. Let's do hydroxide. So hydroxide is right here on our periodic table. So our formula is just OH with a charge of -1. Okay, so does that make sense? Because if you notice, all the formulas that we give you for your homework, none of these have charges. None of them. They only have your element symbol and subscripts. Okay, so if we ever ask you for a formula, they should not have a charge. Okay, and then also on your homework, when you are writing the names of your compounds, you must use Roman numerals if you have a transition metal. Okay, so if you have a transition metal, you have to include Roman numerals. If it's not a transition metal, then you don't have to worry about charges. You can just go ahead and name it as is. Okay, again, if you guys have any questions, please let me know so I can help you guys out. Okay, we do have a quiz on Friday, and then our test is next Thursday, so please ask me questions. Okay.